In this section, I'm going to talk about unconformities. And unconformities represent missing time in the geologic rock record. Rocks represent time in the geologic rock record, and so when they're missing, you're missing that time period at that location. So generally, unconformities are erosional surfaces, because that's how you actually remove the time. There were rocks there, then they were eroded away, and they're no longer there. Then at some later time, new rocks are being deposited on top of them. So there's three different types of unconformities, and the first one we're going to talk about is angular unconformities. And these involve basically 4 steps. So you have deposition, uplift and tilting, erosion, and deposition again. So if we were to sketch this out, so we have deposition of rocks. I'm just going to draw 1, 2, 3 layers. And then up here, we just basically, this represents water, and you're depositing rocks. Then at some later time, the sea recedes, and the rocks are uplifted and tilted. Then, when you're in a mountain belt, generally what happens is you end up getting erosion. So the surface is eroded down, and now you only have 2 layers left, but they're still tilted. And then finally, deposition occurs again. So you get your layer 1, layer 2, and then this represents, this represents the erosive surface, so this is layer 2, and then this would be layer 3. And so this right here is the angular unconformity. It's the erosional surface that's here that now has new horizontal rocks deposited on top of it. So the second type is disconformity. So in a disconformity, you basically have uplift and erosion followed by deposition. So you have uplift and erosion without tilting of sedimentary layers. So you still have deposition at step 1. Then you have uplift and erosion, so you get this. You're skipping the tilting so the layers stay horizontal, so you start with this, your deposition. So we have one, two, three. We have our water. So we have deposition. Then we have the sea receding, and we have erosion. Then we have deposition again. So this is new deposition. And this is the disconformity. So with these, you're dealing with all horizontal sedimentary layers. Sometimes they're hard to see because if you have similar rock types above and below the disconformity, it can be hard to determine out in the field, and usually they have to use fossils in order to do that. Then the third type we have is a nonconformity. And they form in a similar way because you have to have erosion and uplift. Those two usually work together. But you have a nonconformity, so this is uplift of metamorphic or igneous rocks. So instead of having sedimentary layers here, now we're talking about igneous and metamorphic rocks. So we start here, and so we're going to make this just an igneous rock. ING stands for igneous rock. It's uplifted, and then eroded, and then finally you end up with deposition. So we have our igneous rock down here, and then our sedimentary layers here. So with the nonconformity, this is going to be the nonconformity right here. So you have the igneous rock or metamorphic rock on the bottom, and then sedimentary layers above it. So they're pretty easy to determine, especially in sketching cross sections like you'll see in the lab. They're pretty easy to find.